How fast do wave processes spread? Consider the standard wave equation in, let's say, in one dimension. We are going to include the initial conditions, the initial shape phi of x, and the initial velocity psi of x. Recall that the solution is given by the D'Alembert formula, which is the average of two copies of the initial shape, but moving in the opposite directions, plus the integral of the initial velocity on an interval centered at point x. So this formula implies that in order to compute the value of the solution at xt, we need to know the initial conditions on the interval from x minus ct to x plus ct. What is essential here is that the initial conditions outside of this interval have no influence on the values of x at the point xt. There is nothing special about the initial conditions at t equals 0. We could have considered initial conditions at any later moment of time. The set of all possible points in the past preceding our current point xt is called the past history. To summarize the main idea, the D'Alembert formula implies that any initial disturbances, whether in the shape of the graph or in the velocity, they propagate with the speed not exceeding c, where c is the constant that appears in the wave equation. In fact, if the initial velocity were 0, then there would be no integral in the D'Alembert formula, and the current value of the solution would depend only on 2 points in the past. So the interior points of this initial interval, they wouldn't matter either. Geometrically, if we consider the initial conditions at the point x0 with t equals 0, then these initial conditions will affect the future values of the solution only in the region bounded by lines with the slope c and minus c. That's because the disturbances cannot travel with speed greater than c. This also implies that the initial those initial conditions which are concentrated on some interval, let's say from minus r to r, they would affect the future values of the solution only in the region shown on this picture, again bounded by the lines with the slope minus c and c. That was the case of one-dimensional wave equation. The wave equation in higher dimension often has some additional properties. For instance, in three-dimensional space, it will turn out that the initial disturbances will not affect interior points inside of the region shown on the picture, but it will affect only the solutions along the boundary of this region.